That's also part of the note. Well, I think blue sheets. Please fill in the blue sheets on the Etherpad on the very end. The Etherpad URL has been sent around. This is part of the agenda. Please fill in. This is the agenda for today. We're currently the agenda bashing in the blue sheets. We have two current business presentations, the Young Types and the DNS cookies from Ladislav and Willem, respectively. And we have three new business, working group new business. The DNS timeout draft has been presented earlier. We have a second presentation now. It was originally scheduled at the Singapore working group, but it was bumped because we had more time for discussion. We needed more time for discussions. There's also a chair action with the question adopt or not. We'll ask the working group today, but also on the mailing list, of course. And there are two new drafts not presented earlier by Schumann and Dimitri later this afternoon. Okay. Any comments on the agenda? No? Okay, thank you. So then I want to go to the first presenter, Ladislav. I will show the slides, Ladislav, and you can say next, and we go to the next slide. Give me one moment.
Hi, can you hear me, by the way?
Yes, excellent, thanks. Yeah.
Okay, great.
See how this works, if it goes well. Okay. Sharing, open. Okay. There we go. There we go. Do you see all the slides? Do all of you see the slides?
Yes.
Yep. Thank you. Okay, let's please go ahead.
My audio is now somehow broken. I don't know if, can you still hear me properly?
Yes, I do hear you quite loud and clear.
Okay. So I am Ladislav Hudka, and Petr Špaček is the other co-author of this draft. Next slide, please. Yeah, so this is just a recap what this draft is about. We basically took two INR registries that are important for DNS, namely DNS classes and resource record types. And this draft attempts to translate these registries into Yang data types. It means into a form that's suitable to be used in the Yang data modeling language. This document only provides an initial revision of the Yang module. The idea is that after this document is published, IANA will publish the Yang module on their pages and then keep maintaining the module independently of this RFC. So this RFC is really for the initial revision of the Yang module. Next slide, please. There have been two bigger changes to the draft since the previous individual revision. The most important one is that now, instead of having really the initial revision of the Yang module itself, the draft now contains an XSLT style sheet that can be used by IANA for generating the initial revision. I'm going to explain it in a moment. And then the other change was that the two statuses used by IANA, namely obsolete and deprecated, are now mapped to a single Yang status, namely obsolete. I will also talk about that in a minute. Next slide, please. So if you look at Appendix A of the draft, you can find an XSLT style sheet there. And this style sheet can be extracted from the document easily using the well-known tools, and then using two other ubiquitous tools, namely curl and XSLT proc. This is just the command line that can be used for generating the complete text of the initial revision of the Yang module. So this change should solve the concerns that were expressed previously about the fact that the future RFC would stay unchanged, even though the module itself would develop and would be maintained and updated by IANA. So the concern was that somebody may come later and use that module from this RFC, including some deprecated, possibly dangerous items from the IANA registries, which is of course not welcome and not intended. So this way we can see this. IANA will generate the module at the moment from the status of the registries that will be current at that particular moment. And in fact, if anybody happens to use this style sheet again later, he or she can also generate the then current status of the registries. The only difference from the official Yang module will be that the history of revisions won't be included. That's because the revision history is not kept in the IANA registries themselves, so it's simply impossible for the style sheet to include it. Last week, I also asked IANA about their position towards this style sheet, whether this procedure is applicable for them. I haven't received any response yet, so hopefully it will be acceptable for them, because as you can see, it's really quite easy to generate the module. Next slide, please. This is about the semantics of obsolete and deprecated. Unfortunately, there is this discrepancy in the meaning as it is used by IANA and in Yang. For IANA, obsolete means that it's just a statement of the fact that something is no longer in use, whereas deprecated means that some item is not recommended for use. It may be a weak encryption algorithm or something like this. Whereas in Yang, obsolete really means some strong no or relatively strong no, whereas deprecated is quite liberal. As you can see, it's an obsolete definition, but it permits new implementations in order to foster interoperability. So of course, this is not something that we would like to see. And for the time being, we decided to map both IANA terms to the obsolete term, which is like a strong no in Yang. Because this discrepancy could be fixed but it can be done only in the next revision of Yang, the language. And basically this meaning of obsolete and deprecated comes, it's a legacy from the times of SNMP and SMI. But I have already raised this issue in the NetMod working group. Hopefully it can be done in the next version of the Yang language, but it's not going to happen anytime soon. So I think this fix for the time being is quite satisfactory, and hopefully we can use it immediately. Next slide, please. These are the proposed next steps. We received a few recommendations, a few suggestions for improving the text. So we will implement these. in a 001 revision of this draft that should appear soon after this meeting. And the authors now believe that the document is ready for working group last call. And in this case, it should also include a review by one of the young doctors, except myself, hopefully. So somebody else will look at this from the young point of view and find some problems if there are any. But other than that, I believe that there is not much to do on this document, and that we can really move it forward in the DNSOP working group. So that's all I have in my presentation. Thank you. If you have any questions, I am ready to answer.
Thank you. So for everyone, if you have a question, plus Q in the chat window in WebEx, please state your name and your affiliation. So far, I don't see questions. Joe.
There's one.
Joe, Emily. Yeah. So one moment, Ladislav. Joe, please go ahead.
Hi there. Can you hear me okay?
Yes.
Okay, good. So I'm possibly just a bit out of touch, and I apologize if so, but your slides suggest that the IANA is not already in the practice of producing Yang modules from registries, and this would be new for them. It does seem like that is an important part of defining these modules in this document, because I think a lot of people have had concerns that the document otherwise will be out of date as soon as, for example, somebody else specifies a new RR type. So are we correct that this is kind of hinging on the response from the IANA and their ability to keep the module up to date with the registry?
No, just let me explain. IANA already has a few modules like this that are based on other IANA registries. For example, interface type. Interface types was the registry to be translated in this form. But so far, IANA was used to receiving the initial revision in a form of an RFC, and then maintain this module using their procedures. I am not sure what these procedures are actually, but because of the objections in the DNSOP working group, we had quite a few discussions with the chairs and with Paul Walters, who was the most vocal person to object. And so in the end, we found the solution. Instead of publishing a fixed text of this initial module, that we can use these like templates in the XSLT form, so that IANA can and should be able to easily produce this initial version themselves. So the only thing that's not clear is whether this new method of producing the initial revision is acceptable for IANA. I hope that it should be, because it's no rocket science to run those two easy commands. And IANA already replied to my question. They said they will look into it and try to use my instructions to see if it's doable for them. So I hope it will be done for them. Other than that, they are quite, I would say, quite used. There is a page under IANA that lists quite a few of these modules that are based on the registry. So I hope there will be no real issue with this new method, but I haven't received a response yet.
Okay, that's very clear. Thanks. I see Michelle's in the queue, so perhaps you're about to get a response.
Thank you. Michelle Cotton.
Hi, Michelle Cotton from IANA. So I don't, Ladislav did send us some information on producing a Yang module, and we have been testing it out, and I think that it's going to be okay. I guess I haven't seen this document yet. Is this not, is this in the data tracker yet?
It should be there. I think it's there.
might have been looking up the wrong draft string. So I think it'd be great to do an early review of this document to make sure that if we do have questions early, we can get them straightened out and answered way ahead of time of IETF last call. That would be extremely helpful. Thank you, Joe. I was looking at the wrong draft string, so that explains that. So we'll go ahead and take the action now to look at this as an early review and provide some feedback back, looking at the entire document and what's going to be asked of us. So we'll go ahead and take that action.
Okay, so I can send you the pointer, or the chairs can do it as well. I noticed that the data tracker has gone mad a bit in the last few days, so let me check. I hope it's still there, the draft.
Yeah, no, it is. I was looking at the wrong draft string. So we're good. We're going to take a look at that, and we'll send back feedback and any questions we have.
Thank you very much, Michelle. That's very positive news. So, any other comments, questions? No? Okay. Then I want to thank you, Ladislav.
Okay, thank you.
Okay, next up is Willem Torp with the DNS server cookies. I will.
Yes.
Yes, one moment. Okay. Are your slides up now?
I'm sorry?
Are your slides up now? Yeah, I see.
Those are my slides.
I don't have the same perspective as you have, I think, from the, so it's for me, it's as if I look at my own desktop, but great.
Okay. So this draft is an update on RFC 7873, the document describing DNS cookies. It's addressing an issue which operators experience with Anycast server sets using authoritative name server software from different vendors. Next slide. First, I explain quickly what the purpose is of DNS cookies and the issue this draft addresses. So, by DNS cookies, UDP services that reply with a bigger response than the request that came in, like DNS, are susceptible to amplification denial of server attacks. This is the kind of attack in which an attacker spoofs the victim IP address, possibly from a botnet, to flood small requests that results in large answers which are sent to the victim's IP address and as a result clock the victim's connection. So DNS cookies are a DNS native mitigation against these kind of attacks. Now that protocols on top of TCP do not have this issue thanks to the TCP handshake. Next slide. And this is precisely how DNS cookies achieves its purpose too. It introduces a handshake. So how does that work? A client creates a client cookie, which is basically a nonce, and sends it alongside the DNS request in an eDNS option. The server creates a server cookie based on the client cookie, client IP address, and the secret, and then returns that with the DNS response packet. And when the client needs to query that server again, it sends the server cookie it learned for that server with the query. The server can recognize its own cookie and change response policies accordingly. Did the client present a valid server cookie, large answers are allowed, and the client will not be subject to response rate limiting. I don't know who made this sound, but that was not at my place. Next slide, please, though. So now this was all good, but turned out to be problematic in multi-vendor Anycast sets. RFC 7873 did not give a precise recipe for creating server cookies, with as a consequence that cookies created by software of one vendor could not be recognized by another vendor's name server software. Our draft is addressing precisely this and gives a precise recipe for creating DNS server cookies, catering for Anycast sets that contain different vendor implementations. Next slide. So the first proof of concept implementations were done 1 year ago at the hackathon of IETF 104 in Prague. And it was a huge success. So implementers of the different open source DNS software vendors managed to create interoperable server cookies. So, next slide. Mission accomplished. Well, almost. The draft was not working group document yet, and also the authors of RFC 7873 had worked on an update too, addressing things we did not address in our draft yet, such as directions for safely updating and rolling server cookies. So, next slide, please. We merged with Donald Eastlake and Mark Andrews' efforts on updating RFC 7873. We incorporated input from the DNSOP list. We added a section on how to correctly and safely update and roll server cookies. So next step, implementation experience. Next slide, please. So at the hackathon at the IETF 105 in Montreal, the same people that worked on it at the previous hackathon continued their work on implementing the new server cookies, taking along the updates, and now also taking note on how to create a client cookie. So for privacy reasons, client cookie was basically a hash based on the secret and the server IP address for minimal authentication of the server, and also for those privacy reasons, the client IP address, so that clients cannot be tracked based on their cookie when the client IP addresses change, for example, due to IPv6 privacy extensions. But that turned out to be problematic because, next slide please, on a UDP socket, which has not been used to send out a query yet, the client IP address is not easily available. There is a way to determine it for a destination, but it's involved and ugly, and none of the implementers wanted to do that in the critical part of the code base that's called for every outgoing query. Next slide, please. So instead, we changed the constructing a client cookie text to state that we recommend to disable DNS cookies when privacy is required. Also, the spec got adopted by the working group, that's IETF. So despite that it might not have been our ideal spec, we thought it was good enough for the purpose of addressing the multi-vendor Anycast sets issues with DNS cookies. So, next slide, please. Mission accomplished. Next slide, please. Except then there was this flaw that was brought up on the DNSOP list by Philip Homburg. Besides privacy, having a client cookie associated with the client IP address has a role in server cookie creation too. When a client changes its IP address regularly, such as, for example, in situations with multiple gateways, servers will not recognize their own cookie anymore, because it's based also on the client IP address and on the client cookie, which in such cases, such settings change frequently. So, next slide, please. This was not easy to get exactly right immediately, but we managed, with great help from Philip Homburg, to come up with a control flow which has the same effect of including the client IP address in client cookie creation without having to have access to the client IP address before the query is sent out. And this works as follows. For each newly seen server, which does not have an associated server cookie, we create a completely new random client cookie. If the server returns the server cookie, it's registered for that server together with the client IP address, which was used for the query. which at that point is available. Then when that server is queried again, the client will make sure the query will use the IP address that was used earlier on, for example, by binding or using a bound socket. And if that fails, the client IP has changed and all cookie states should be reset for that server. New client cookie needs to be created and so forth. So it's a bit more involved implementation-wise. We have to intelligently deal with servers that do not support cookies too, for example, but this is the general gist. Next slide, please. So at the hackathon of the IETF 106 last fall in Singapore, we wrote this all down precisely right and created version 2 of the draft with a rewritten construction and client cookie section and a new security and privacy consideration section. So we thought, next step, implementation experience, probably at the next hackathon. Next slide, please. So at the, these are the results of the hackathon at the IETF 107, which unfortunately did not happen. That said, next slide, please. I did do an implementation of the privacy-friendly client cookies in GetDNS, which is a step resolver library. And it works as designed, as described in the draft. And it will be included in the 1.6.1 release, which will be done shortly in 2 weeks or so. Also, I've had reassurance from Witold from IC that client IP addresses are tracked good enough for adequate implementation in bind. Next slide, please. So where are we now? The primary purpose of this draft was to provide a precise recipe for server cookies for the different implementations, and this has successfully been done. The recipe in the draft is already in use with NotDNS since version 2.9.0 and also with bind since version 9.16, and I believe it also has been backported to bind 9.11. NSD and Unbound have a proof of concept server-side implementation following the recipe. And also, I think that the text in the draft on client cookie construction is sufficient for knowing and considered client-side implementation in resolvers, such as the not resolver, Unbound, bind resolver side. So what's the next step now? So my question to you now is, next slide, is our mission accomplished? And that's the end of the presentation.
Thank you, Willem. Any questions from the room?
Yeah, I have my window open, Stefan.
Yeah. Yeah. Okay, thank you. Okay, I have a question from Mark Groeneweg. Please go ahead.
You mentioned a POC implementation for NSD. When will it be mainstream?
Yeah, so I don't know. So that could be soonish. We sort of have the principle that things will be released without extra compile option only when it's RFC, more or less. Does that answer your question?
Not quite. You tell me you are waiting for an RFC on this. NotDNS and bind are already working with this. So
Yeah.
why not release the NSD code for this?
So maybe we should ask my boss.
He's not present, only the chair
he's
is.
also present. He's chairing the session here. No, good question. So hats off here. If there's an RFC, we will implement it. Yeah. Heads on. Heads on. Mark, is your question answered?
Yes, for now.
Yeah. And any other questions from the room? Then I have a question to you, Willem, and the authors. So the next step question mark is working group last call.
Yes.
Yeah. Okay. So I will invite all the room and all the people on the mailing list to read the document. We will start a working group last call. Well, Tim will schedule the working group last calls, so it will be this week, next week, the week after. So we try to do a call for adoption or working group last call every week. It will be scheduled soon. It will be part of the actions we will publish after this meeting. Any other comments, remarks? No. Thank you. Thank you, Willem. Then next up is Tim or Tom.
Yeah, I'm ready. This is Tom.
Excellent. Thank you, Tom. Are your slides now up in on WebEx?
Yes.
Okay, excellent. Good.
So about I guess a year and a half ago, we released the first version of this draft, and it's been 4 updates. We've got a lot of feedback on the mailing list, but it's never been presented at a working group. We were trying to get some implementation experience, and Mark Andrews has done some of that on an older version. I'm not sure if his has been updated for this latest version. Next slide, please. I'll go over the basics of it rather quickly. It's a fairly short draft. It's intended for authoritative servers, and the idea is that when you install a resource record, there could be a lifetime associated with that record where it makes sense to have that record published. The most obvious case is with an update from a DHCP server where there's a certain lease lifetime associated with the lease of the address attached to a name. But there's lots of other uses as well. There have been a few maybe proprietary and non-interoperable solutions, but no standard solution. And so in discussion with Mark, I decided to write this, and Tim helped me going through a lot of the details. It could be managed by the primary server, where when the records are added, the primary server can do the timeouts of the records that they cover. But there'll be a transition period where they may have to be managed externally through DNS updates. And so you can liken that to either the primary server using reference counting to know when records exist and should be removed, versus maybe garbage collection where an external manager would be periodically scanning to see if a record should be removed. But it does provide a transition mechanism. Next slide. The information that you have of how long that the DNS record should be in the database could be an absolute time, or it could be a relative time. There are, IoT devices out there that would make use of this that don't have real-time clock hardware, so they tend to use a relative offset. And there's already an EDS 0 option called the update lease option that would give you a relative time, and so that then the primary server could create a timeout record based on that information. The main thing we're trying to achieve here is not to lose that lifetime. And so if a server restarts, that amount of time that it received in an EDS0 option would be lost, or if that a secondary has to take over for the primary, that information would be lost. So by storing this, the length of time that the records are valid, by storing that in a record itself in the database and having that synchronized across to the secondaries, allows for a secondary to take over and continue to remove that record at the right time. So it's possible that the timeout records could be included in the update in addition to the records that they cover, and then the primary servers would just install them. There'll be policy for sure on the primary server of what could actually get installed in its database. So there may be, restrictions on that, and I think you're gonna externally, you're going to have to maybe do some testing to see what a primary service would accept and what it wouldn't accept, and what conditions are placed on it. And I think you'll have to have a little bit of discovery there. Next slide. So this shows the wire format of what a timeout record looks like. This is the R data, and there's the represented record type that the timeout covers. The timeout is always going to be the same owner name, class, and I don't remember the last one. It's always going to be the same record for the same record that it represents. The count will show how many hashes, like each record that it represents is represented by a hash, and the count will show the number of hashes that are in the list. The method will show what is the algorithm used for the hash, and the expiry time shows when to remove the record itself. If there are if all of the records that the timeout represent have the same expiry time, then there's no reason to specify hashes for all of them. You can just say no method, and then all the records that match will expire at that time. And so it's a kind of a shortcut where you don't really need to do any hash calculations. It's only when you have multiple matching records with different expiry times that you need to specify the hash for the ones that match that expiry time. The nice thing about using a hash is that it's a hash of the R data of the represented record, and it doesn't matter what the length of the R data is. It will always be a fixed length in the timeout record. Next slide. Okay, so here's a simple example where an update is sent with an A record, a quad A record, and then other updates sent with the pointer records. They'll have a certain amount of lease lifetime, and in this case, it's going to be ln, and the time at which the update was sent is tn. So in the future, it'll expire at this absolute time of tn plus ln. In this case, both the A and quad A records are going to expire at the same time. So you don't have to specify a hash. So the count is 0. The count is the number of hashes. Count is 0, and the method is 0. which is there's no reason to specify hashes. And this is going to be the normal case where there's not going to be overlap between the owner name and the type and the class. So you're going to almost always have no method 0 and no hash. Next slide. There are a few cases where there will be different times, different expiry times with the same owner name, record type, and hash. And record type and class. And a common example may be in the service discovery realm, where you're sending unicast updates for like wide area bonjour or a service like that. You'll have PTR records that point to the different instances of the service. So the R data is different, but the owner name, class, and type is the same. And they'll be coming from different hosts, which means they'll be coming at different times. So the expiry times will be different. So in this case, you have the PTR record and from the two different hosts looks identical. And so in the primary server's database, you're going to have to create hash entries to have the different timeouts for host A or printer A versus printer B. And so on the bottom, you'll see the list of timeout records that you would have, and most of them are still have a method of 0 and no hashes, but only the PTR records have hashes because of the collision there in the owner name, type, and class. So that's about how it works. We've gone back and forth a lot on the mailing list and made a lot of changes over time to answer all of the questions that we got, and made some changes to make it work better with existing implementations, like including the type, the record type. So we're now feel like we're ready to adopt this as a working group document, and so we would like to get people to review it again, and I'd like to move it forward.
Thank you, Tom. Indeed. So please speak up now if you want to support the document, have interest. We want to issue a call for adoption later. Again, Tim will schedule that in the next weeks. I see Joe Abley on the mic. Please, Joe, go ahead.
I had two things to say. One of them was I think another reason for using an RR type for this and not something more ephemeral like an EDNS 0 option or something is that it gives clients on the outside who are not involved in publishing the zone the ability to see what's going on. You can troubleshoot. So if you want to diagnose a problem where a record has disappeared from one place but from another place or something, you might look for a timeout record, and that might give you some clues. And if this information was hidden in, say, the update protocol, or it's like in a pseudo RR that disappears and is not published, then you don't have that diagnostic information. So I think actually spent a lot of time thinking that this proposal looks really quite ugly, but I've changed my mind. I think it's better. So that seems good. So that was just a suggestion, and I don't know whether it needs to be in the draft or not. I just thought I'd mention it. The other observation I had, though, and maybe this is something to think about after adoption, is that I wonder whether this protocol would be simpler if it was just defined only to deal with RR sets. Get rid of the whole hash business, unless maybe it's possible to do that and not eliminate any really, really important use cases, because the protocol is much, much simpler and easier to understand and probably easier to implement if it just works on the unit of an RR set and you just don't accommodate the problem of having different timeouts for different RRs in a single RR set. I think that would make it a lot simpler. And maybe I don't personally see the use cases in my life that would make the hash necessary. So I'm curious as to whether my experience is not global. I see Mark's about to explain this to me.
Thank you. Thank you very much. Next in the queue is Mark Andrews.
There's definitely cases where you need the hash. It doesn't really make much difference internally in terms of what the server needs to support. It's just the regeneration of timeout records as you remove a hash, and that's a relatively straightforward thing to do. It's just remove the record. I can't remember whether the current one has multiple timeouts in there or not. The earlier ones did. But yeah, the Bonjour is the perfect example of why you need multiple timeouts and you're not dealing with an RO set. And internally, well, it's easy enough to track everything, and computing a hash is relatively cheap. So you only need to compute the hash when your timeout record actually comes up for expiry. So you don't need to maintain it and things like that. You don't need to maintain state about the hashes.
Okay, thank you. Thank you. I see another question from Jim. Jim Reed, please go ahead.
Thanks, Benno. Quick question. If we're going to be using hashes, will there be a need for some kind of provision for signaling which hash algorithm is used? Supposing at some point SHA-256 gets deprecated.
Yeah, so we don't want to have a lot of different implementations trying to figure out which hashes other implementations support. So preference is to define a single hash that everyone uses, and that if the condition occurs in the future where that hash is found to have vulnerabilities, and we'll define a new one. There's a registry established in the draft to do this, and then that one will be the one that everyone should switch to. There'll still be some older implementations maybe with the other one, so you'll have to continue to support it if you want to be interoperable. But there's no reason to define multiple types of hashes at this point, though we have the mechanism to do so.
So I wasn't saying defining the hash algorithms, but there must be somewhere we needing to know if there's a possibility in the future that the hash algorithm has to change for whatever reason, that clients can tell this stuff was signed or used the old hash algorithm, this one's using the new one.
Yeah, and so that's what the method is identifier is for. And method one means SHA-256. Method one means the first 128 bits of SHA-256.
Thanks, Tom. And, okay, so method two would be SHA-385 or whatever.
Yeah, or Shake. I initially tried to use Shake and got some pushback there, but
thanks.
Yep.
At some point, we might need to define a new error code to say that this is no longer supported or something like that against the update. But yeah, I don't think it's going to be a real big issue. I can't remember my crypto enough to know which property it's got to be, which property has got to fail for the timeout records not work. But I don't think it's going to end up being a real big problem anyway, because you've got the data there. Got to try and it's only matching the data within itself. So I think we could get away with it, apart from the fact that people don't want to use MD5 or even whatever it was before that. It's in terms of rolling it, we're only going to roll it. It's only going to be rolled because the outcome's gone out of the name server itself.
Thank you. Thank you, Mark. Thank you, Tom. Well, there's a good interaction with also with the software developers previously, I understand. So thank you for the input from the working group. We will issue a call for adoption in 1 or 2 weeks. That's up to the planning from Tim. I want to wrap up this presentation and go to the next presentation. I think Schumann will present. Is that correct?
That's correct. Yeah. So can everyone hear me okay?
Yeah, excellent. I'll show your slides. Open up your slides. There we are. Do you see the slides? So, yeah. Okay.
Yep. So this is a draft that was put out recently by Paul Vixie, Ralph Dolmans, and myself, and that has had a bit of discussion on the DNSOP list already. So I'll go through these slides quickly, but Paul and Ralph, I think, are both here, so I trust that they'll interject comments as needed. So next slide. I'll start with the motivation. Basically, as I think most people know, there is a range of behavior in DNS resolvers today in how they process delegations. And some prefer the parent NS set, some the child, and for many others, the behavior varies depending on the dynamic state and content of queries and responses that they process. So some of our goals in this draft are to try to get more commonality and predictability in the behavior, and to do so in a way that is in accordance with the DNS protocol, and also to solve a set of operational problems that frequently come up. The main recommendations in the draft are that the resolvers should deterministically obtain the child NSRR set during iteration and place that preferentially in the cache over the parent NS set. And number two, to revalidate the delegation of the parent at the expiration of the TTL of the parent NS set. Can we move to the next slide, please? All right, so it is clearly stated in the DNS protocol specifications that the child NSRR set is the authoritative one, and that the corresponding parent NS set is essentially non-authoritative glue. The data ranking rules in RFC 2181 further clarify how resolvers should categorize and treat data of various types, and authoritative data should clearly be preferred. I've just excerpted in this slide some of the relevant rules here, but I'm not going to read them all now. But additionally, the child NS set can be signed with DNSSEC and the parent cannot. And DNSSEC, as you may all know, only signs authoritative data. And the data ranking rules also, as you might suspect, state authenticated data is to be preferred. In case anyone thinks these are general rules and maybe the NS set is special and could be excluded for them, I don't think that's true either. I neglected to put it on the slide, but I think 2181 at some point says something along the lines that NS records corresponding to a zone cut are the property of the child zone. So this is not happenstance or oversight, but clearly intentional. Next slide, please. So how does the resolver get the child NS set? The DNS protocol, after all, does not require resolvers to explicitly fetch it. So they usually see it when authoritative responses coming from a child zone include the NSRR set in the authority section of their DNS response. And then data ranking rules dictate that this should be then placed preferentially in the cache. So the behavior of adding the NS set used to be almost universal, but authority servers are not technically required to do this. And the trend these days is towards minimizing unnecessary data in responses. So, for example, very popular DNS implementations these days are now defaulting to this so-called minimal responses configuration. So with minimal responses, the resolver wouldn't see the child NS set at all, unless some downstream client of the resolver issues an NS query. And this is not something that normal end user applications do, as far as I know, so we can't rely on it to occur with any regularity. So we think we need a systematic way to observe the child NS again. And the draft recommends that when following referral responses, resolvers should issue an explicit parallel query for the NS record at the child zone. Next slide, please, Benno. So in theory, the parent and child NS set content should match, right? So unless people have misconfigured things. So who really cares what resolvers prefer anyway? The main reason I wanted to point out that you might care is that although the contents should match, the TTL often does not. If the child zone is authoritative, they can dictate the TTL that resolvers should actually honor. And this allows them to more rapidly make changes to their name server configurations when needed by temporarily deploying a short TTL so that they can not only more quickly make those changes visible, but also more quickly back out those changes if things go wrong. Next slide, please. So Ralph, with his implementer's hat, wanted to make sure I mentioned this note. The NS query need not bottleneck the FastPath. It can be sent in parallel and be processed opportunistically and does not need to delay resolution of the query that actually triggered the referral processing. And I'm just going to quote Ralph verbatim here. He says, not much risk, little complexity, and no speed difference. The opportunistic nature of this query also allows resolvers to deal with the small subset of broken authority servers that don't respond to explicit NS queries without incurring any performance penalty. Next slide, please. All right, so now moving on to the second part of the draft, which is delegation revalidation. We state that resolvers need to recheck the parent delegation at the expiration of the TTL of the parent NS set at the very latest. So this prevents an important security issue arising, namely a child zone living beyond their authorized lifetime if, for example, the parent has removed the delegation or redelegated the zone to another party. So without revalidation, this situation could arise if, for example, the child zone operator maliciously set a very long TTL in an attempt to artificially prolong its life in resolver caches. It could be done by accident, I suppose, also, or because resolvers that do prefetching of DNS records, which is becoming more common, continue to inadvertently prolong the life of the child zone. So this, by the way, is not a theoretical problem, but one that has been observed in the field. There are a number of research papers going back a few years that talk about this topic. You can search for ghost domains if you like to locate them. Next slide. So how should we implement revalidation? The simple and probably most obvious scheme is to just cap the NSTTL in your cache to the lower of the parent and the child NSTTL. But this draft also presents a more detailed algorithm that deals more effectively with some more involved corner case configurations. And the last bullet item on this page is not in the draft yet, but it came up in mailing list discussion. Brian Dixon, if I recall, suggested it, and it was backed by others, that if all child servers are assessed to be lame or unusable, that should automatically trigger a revalidation action at the parent zone. So we agree, but it would have to be done in conjunction with a hold down timer of some sort to avoid inflicting unintentional DOS on the parent zone. Next slide, please. So just want to mention these ideas are not new, of course, by any stretch. Paul and others wrote them up in the ResImprove draft of 2010, which I think many people are aware of. Wouter Weingart's also proposed something like this in his resolver mitigations draft from 2009. And the Unbound resolver from NLNet Labs roughly implements this today with a configuration knob called harden referral path. Next slide. And this is the last slide. So discussion around this draft has predictably caused a related discussion about whether we need to like totally overhaul and redesign the DNS delegation mechanism. We are not attempting to do so here. This draft is proposing a minimal set of changes to improve things. It doesn't require any wire protocol changes and can be done unilaterally by changes on the resolvers. That said, there are undoubtedly deficiencies in the zone delegation mechanism that could be addressed with the redesign. I'm personally interested in that subject, but that could be the subject of a much more ambitious effort, and it isn't clear whether it could be successful given how entrenched the current DNS is. So I'm just going to stop there, but before I turn it over for discussion, I just wanted to quickly check with Paul and Ralph to see if there was anything I missed or misstated.
I think you had it all, Shimon.
Okay, thank you, Ralph.
I have since realized that if the authority server is not doing minimal responses, then we can treat its additional data as adequate and don't need a second query. But that's an optimization. What you presented is all true and correct.
Thank you. I think we're ready for questions and discussion.
Okay, thank you. Thank you, Shimon. First in line is Warren Kumari.
So Warren Kumari for the record. So slide 9 actually answered much of my question, but there was a lot of other stuff in ResImprove as well. And I just wanted to say that a lot of that was also useful. And so I hope that, ResImprove can also move forward at some point.
Yeah, so I think if this draft actually moves forward, Warren, we have covered everything that was in the original ResImprove draft. The main additional item in ResImprove was what's called clarifying what NX domain means, and that has already been republished as RFC 8020, if you recall.
Awesome. When?
Thank you. Next question in line is Stefan.
Regarding the issue of explicit NS queries, just want to remind that we are also discussing draft RFC 7816 bis QNAME minimization. On one of the big changes in the draft with regard to the old RFC is about explicit NS queries, because in RFC 7816 a QNAME minimizing resolver used NS queries, and now there is a change to prefer A queries, because one of the reasons being that many don't know, authoritative resolvers time out on explicit NS queries. So both drafts are related in that way.
Yeah, that's a very good point. Sorry, there's echo here from someone. I'm going to ask Ralph to comment on that because he has some opinions, but we are aware of that, and this is one of the reasons why the query is opportunistic in nature. But Ralph, do you want to chime in?
Yeah, sure. Yeah, so I'm involved in both drafts actually. So the difference indeed here is that this one is opportunistically. So if the NS query fills here, it is all fine. And also, if we would do QNAME minimization with the NSQ type, then there are still cases where you won't send the NSQ type to the apex, because if you are going to resolve a name that's where the original QNAME is the same as the name for the apex, there's no delegation there. You already sent with the incoming Q type. So even if we would do QNAME minimization with the NSQ type, it would not cover all cases.
Yeah, that answers the question. Thank you. Last question by Jim. Everybody still around?
Yeah, forget Jim is me, Daniel. So it's Daniel Migo.
Oh, Jim, sure. Yeah. Okay, Daniel, please go ahead.
So I like this kind of work. It's something we touched a little bit in our recommendation for DNS validator. So I support this kind of work. The question I would have is, why do you consider to cap the NSTTL based on the NS of the parents and maybe not the DS record?
Yeah, so that's a good question. I mean, I guess we could cap it based on the DS if it were the case that DNSSEC were ubiquitously deployed.
Okay.
Since it isn't, we can't really rely on it to cover the revalidation case that we need to happen across the board. In theory, at least, the DS record, if it is present, is supposed to, by the DNS protocol specification, have the same TTL as the delegating NS set. But as a practical, zones are not signed and we do have to deal with it. We can't rely on DS.
Okay. Sounds good. Thank you.
This is Paul. I'd like to follow up. There's no reason in principle why the TTL of the DS record cannot be part of the equation of choosing the revalidation interval. Because if it is expiring differently and sooner than the parent NS, then there's no problem with revalidating it when it expires. However, that is what a DNSSEC validator will do. So we did not feel a need to mention it.
Yeah.
Okay, so, sorry. It was a little bit abrupt end of Paul. Paul, are you still on?
I'm sorry, that concludes my remarks.
Okay, thanks. Yeah, maybe it's on my side. I have some network problems. Thank you. Concluding, so there has been some discussion on the mailing list. The chairs also followed a discussion on DNS operations mailing list, so on the OARC list. So I think from the room there were questions, and I think it's positive. I'd like to see a little bit more discussion on the mailing list. To be fair, I haven't read up the last emails on the DNSOP, our own IETF DNSOP mailing list. But we will issue a call for adoption later. I don't know when to schedule that, but before the next IETF, virtual IETF. But I'd like to see a little bit more discussion also on the mailing list. Yeah, I think the draft is quite new. How many people, Schumann, Paul, and Ralph, you already have seen a lot of comments, feedback on the document?
I think we've seen a fair number of comments. I guess you'll have to judge how much discussion you want to see happen before calling for any specific action. But there's been discussion not only on the DNSOP list, but also on the OARC DNS operations list.
Yeah.
And I think it's continuing to happen. So if you feel like we should continue that until we get additional comments from a larger set of folks, I think that's fine with us.
Okay. Yeah. I don't want to put a time frame on it, but the chairs will look at the ongoing discussion and then kick off a call for adoption.
Yeah, I think this is Suzanne. I think we can see this. It would be good to see the 01 and see where discussion goes. So thank you very much.
Okay, thank you.
Sorry, Mark, I closed the queue after Paul Vixie.
Comment the bind already implements the timeouting, and it's been doing for over a decade.
Okay, thank you. Thank you for all your inputs and feedback. Then I want to go to the last presentation by Dimitri. Give me 1 minute to bring the slides up.
Hello, can you hear me?
Yes, excellent.
Okay, now I'm waiting for slides. Okay, thank you very much. Thank you. My draft introduces the Russian ghost profile for the DNSSEC. Next slide, please. Russian ghost algorithms were introduced into the DNSSEC in 2010 in RFC 5933. This RFC specified using of the algorithms ghost R3410 2001 for digital signature, ghost R 341194 for message digest for DS record. But unfortunately, both of these algorithms are deprecated in Russia since 2019. Next slide, please. As we in Russia have an interest in reintroducing ghost to DNSSEC, here is the new draft. Here is the link to the implementation of the profile, of the suggest profile. The new profile prescribes using new ghost digital signature algorithms described in RFC 7091. With digital signature parameters introduced in RFC 7836 and message digest described in RFC 6986. Next slide, please. So this document was designed to update RFC 5933. But as it provides additions to IANA registries, there is no problems with DNS security algorithm numbers registry. Its policy implies RFC required. But as adding new DS type digest algorithm requires standard action, it means that the document doesn't fit independent stream requirements. So in these circumstances, I have to ask the working group to adopt it as a working group document. And I hope that it will be done. Many thanks. That's all for the presentations. So ask any questions.
Thank you, Dimitri. I see one question from Stanislav. Yeah.
Yes. Hello, everybody. In fact, I would like to support this work because I think that is in favor of crypto agility of the DNSSEC. So I support this, and I hope that it can be used at least inside Russia. Thank you, Dmitry.
Thank you.
Okay. Another question here from Valerie. Please go ahead.
Valery Smyslov, LS+. I also support this work because the algorithm, previous ghost algorithm, had some weaknesses, and they definitely need to be changed. And there is no way to do it other than standard process. So either as draft should be adopted, or authors should seek for AD sponsorship. But I think that since the DNSSEC group is non-concluded, probably this working group is maybe a home for this draft. Thank you.
Thank you. Jim Reeds, next in queue.
Thanks, Benno. Just a very quick question. I support this work. I think it needs to be done. but just also make sure that those references to the earlier now deprecated crypto algorithms and RFCs for GOS DNSX signing, we should make sure those get marked as being deprecated or obsoleted or something like that. I haven't been too quick in actually going to check that information in the IANA registry, but I'm just making that point here now.
Yeah, thank you, Jim. Good remark. The last person in queue is Warren.
Thanks, Warren Kumari as AD. So yeah, I was originally asked if I could AD sponsor this, and I felt that it was much better if it went through DNSOP. We have a group which this fits well in, and so I think it should be discussed here. But a reminder that our main thing to do is figure out if this works correctly with DNSSEC, not discussions on the algorithm, the GOS algorithm itself. So hopefully this can go through here and can go relatively quickly.
Okay, thank you. So given the first comments on in the room, and Suzanne, please correct me if I'm wrong, but I think we will schedule this draft for a call for adoption somewhere later after the meeting. And please, ongoing discussions on the mailing list are more than welcome. Feedback, comments. Any other questions, remarks on this draft? No? Time-wise, we're running a little bit out, so I already warned everybody we would run into 16 or 4 o'clock in 15 minutes UTC. It's now 4 o'clock 20 minutes. Before I want to close the session, I want to give the opportunity to people to ask a more general question, not related to the drafts. Any comments, questions, points for improvement? Oh, I shouldn't ask that. Okay, good. So summarizing, we have a number of call for adoptions that will be scheduled. For the draft IANA Young, we're close to a working group last call, but we want to make sure that the IANA process will work. So that's the first step, and then we will go for the second step, and that will be a working group last call. The DNSOP will go to working last call. Let's help me out. That was the timeout. We're also going for the call for adoption. Will be scheduled. The revalidation NS will also be, after some discussion, go for call for adoption. And the very last presentation on GOST signature algorithms will also be scheduled for call for adoption later this month. If I miss some action points, you probably will see that in an email sent out by one of the chairs. I want to wrap up the session. I want to ask everyone, if not done yet, sign the blue sheets on the Etherpad. This is your very last moment, opportunity to say something. If I forgot something to mention. No? One, going twice. Well, I want to thank you for your time and for your input and for the, I think, very productive meeting.
Thank you very much, everybody.
Thank you.
Bye-bye.
I will stop the recording now.